Alright, should be a video. It should be a video. Should be a video. There we are. Should be a video now. I can never tell when it really starts. Well, I don't know if you can never tell. If you're an expert, maybe you can tell. But I'm not. So I couldn't tell exactly what I had until I had it. Alright, so the video is started. So that's good. And now we'll find this Ian Gosling guy. He's just so obnoxious. Anyway, yeah, I guess you don't need the background yet. I guess we'll get to that. So he's done another lever experiment. I guess we'll play a little bit of it, but I mean, I don't know if there's much point.
Mark II of the lever system.
And
I've got new springs to try and make it slow enough, the movement, so you can see the difference in the inertia. These weights about...
I guess you could get looser springs, but whatever. The whole idea of putting springs on it, doing all this stuff, just doesn't make much sense. So anyway, I guess we'll just draw what he's saying. Okay, that somehow he's going to prove there's no conservation of momentum. Okay, that's what his proof is. And obviously, that's a pretty bold thing to be saying you're going to prove. And he's not going to. Obviously, he's not. Let's see, where to put this stupid thing? Up here, maybe. Maybe that'll work. Just once we get rid of that, then that'll be fine. Maybe. All right, that'll be good enough. All right, so I didn't erase yesterday's drawing. All right, there's a little piece of it right over here that's relevant to this. Yeah. Let's see, microphone's on, all that kind of crap. Well, it probably is. Oh, Jesus, all the little details. Anyway, so this little bit down here, which I'm going to have to fix this camera resolution. Damn it, it's always something. Now, see, it looked really good for a second there, so obviously it needs some sort of something like that. All right. So these are, you still can't see it very well. All washed out. That stupid white balance. I gotta quit it doing it automatically, I guess, and do it. Let's see, gain. Maybe that'll help. That's sort of the ticket. All right, let's see if it stays that way. All right, so if you were to roll two objects that were the same down a ramp, okay, so they're the same size, even though these don't look the same size, and you put a 2 mass here on the inside, and then twice the distance from the radius, you put a half mass, and you spread the weight out over the wheel. I mean, what do they actually think is going to happen? I mean, is there any real choice, momentum-wise, that, you know, gravity's going to move them at the same velocity? And the fact is these are going to turn at the same rate because, yeah, half the mass at twice the velocity is the same thing as the full mass at half the velocity. Yeah. So what's their prediction? So it's another semi-simple experiment to do. So what he's doing now is making this argument that, all these little details. You know, I've just made this simple point about levers and made an argument about how they function. And, you know, in the context of, I was talking about a lever where you actually balance against another weight, and the weights would be dangling from the lever, and so you could understand that a 2 mass here is going to equal a 2 mass here. Okay, and then if I did put, just extend this a little bit, if I put a 1 mass out here instead of this, all right, then I'd have the same balance to this fulcrum. And you know, it'll oscillate fine. I did it with a 4-to-1 ratio, and it, you know, oscillated just fine. And it oscillated just fine in the sense that this moved twice the distance that this moves in the same amount of time. So obviously this is twice the velocity. No doubt about it. And there's absolutely no reason to think that if I gave that oscillator a little more energy, and it was enough energy to actually launch the objects off the lever, that they would launch at the same velocity that they're actually traveling at. And this would go 1v, and this would go 2v. And if they shot them up in gravity, this would go 4 times the distance. Okay. All right, that this one would go. And all that's, you know, those are well kind of established truths, so I don't know where the argument is here. What exactly are their argument? And so he's trying to claim that somehow when I make a lever and I use a spring instead, so we're just going to use a spring to create some sort of tension on the lever, and then he's going to replace, we'll call this the fulcrum, he's going to replace a 2 with a 1 out here. Alright, and he's going to argue that somehow this has more inertia, okay, whatever inertia is. That somehow this isn't going to be able to move as freely as this is, so it won't go twice the speed, it goes to some other speed. So even though it's the same weight, like if you press down on here, it's going to read the same lbs, the same pounds, somehow this is harder to move. So even though it weighs exactly the same, it somehow resists being moved, and this somehow doesn't resist being moved. And he just keeps saying it. And I'm saying, well, you can keep saying that crap, but I don't know what your inertia is. What are you talking about? It's the same. Rotational inertia, rotational momentum is exactly the same as any other kind of momentum. You're just talking about a velocity. And so you just take the curved line and make it a straight line. Okay, and you figure out what the velocity is. It's not at all complicated. And there exists for doing angular momentum, there exists the same 2 formulas, one with the v plane and one with the v squared. Okay, one's a kinetic energy formula essentially, and one's a momentum formula. So it's the same kind of bullshit. So you have to pick an answer. One of them's going to say there's 300 joules of energy. The other theory is going to say there's 150 joules of energy. It might say it's in newtons, but it can be converted into joules easy enough. So, I mean, where are you advancing anything with this experiment, in the sense that you're just basically saying that you're going to prove there's no conservation of momentum, that I can have the same force here and I can get different amounts of force out here, force X and force Y, and that I don't have to account for what happened to it. I mean, just saying inertia isn't explaining anything. Saying inertia destroyed the force somehow, that's not an explanation. You have to explain that there was more friction on the bearing or something. Something did something to use up the energy. You can't just say the energy got used up by some magical inertia. Except that's all he's going to say. I mean, he's going to keep saying that somehow he's refuting or disputing something when I'm saying he can't get to this elemental conversation. He refuses to talk about how he understands this kinetic energy thing to work. He won't touch the argument that it's, gravity is a time-dependent force, 9.8 meters per second. He won't say those words and acknowledge that it's per second that you collect that much force. Not per mile, not per meter, not per millimeter, per second. And this fall is only 2 seconds. It isn't 4 seconds. So you can only collect 9.8 plus 9.8. You can't collect 9.8, 9.8, 9.8, 9.8. So again, we've been over this so many times. They refuse to have the theory argument. They refuse to argue the principles, the laws, the rules that physics has, and those fundamental declarations about how things function. And the fundamental argument all physics concedes is they must conserve momentum. If you don't get the same momentum, then you have to explain where the energy went. You have to explain where it went. And they won't do any of that. Alright, so we'll play this piece of crap. Here, I'll explain, so I want them to argue the theory. I want them to explain how their theory makes sense, how it works with a lever, how they can get twice as much energy on one side of the lever than the other side in the oscillator. I want them to explain all that, but they refuse to. So what he's done in this another defective experiment, okay, where he's not proving anything. So he's not proving the 1.4 thing here. He's just saying that somehow they oscillate at a different rate. So obviously they have a different amount of energy in them, but it doesn't come out to 1.4. There's no evidence that the energy loss is consistent with his kinetic energy theory. His theory doesn't predict this outcome. It's like Brozo's 14 answer when the two predictions are 12 and 16. It's really garbage as information right on its face because it doesn't demonstrate kinetic energy. So he's saying I'm proving there's no conservation of momentum, but he's certainly not proving there's conservation of kinetic energy because the differential in the oscillation isn't great enough to account for the kinetic energy problem. All right, and so he ignores that he's really not making anything called a sensible argument. So anyway, his fundamental error in this case, okay, there's always errors in what they do. So yes, not having a quick release is an error. Lots of things are wrong with the experiment. He does the experiment and shows you, the both of them are supposed to be doing the same thing, and they're clearly not doing the same thing. Clearly showing one of the levers has more freedom of motion than the other lever has. So lots of defects like that. But a major defect is that he has a bolt in here and a bolt in here. Those are effectively just weights at these locations. And because he's not using a counterbalance, that is, he's not using a counterweight that will move the same as these weights in reciprocal fashion, he's using a spring. Then he puts another weight on top of that weight. So he has these washers that he puts on top of those bolts. Well, the bolts are already a mass at this location, and this bolt's a mass at this location. So when you switch, you're not switching from say 12 ounces of how much the washers weigh. It's the 12 ounces plus the 5 ounces of the bolt. So it's a 17 ounces in this location. And now he's going to move 12 of the ounces out here by essentially putting a 6 ounce, right? Because it's twice the distance, it's only 6 ounces. But for the bolt, it's actually twice as much weight. So it's 10 ounces for the bolt out here. So the bolt that weighs 5 ounces here weighs 10 ounces out here. And so now he's adding, technically 12, in terms of weight, okay, to 10, to get 22. So he's going, these differentials in the numbers are the problem. So he's going to be stuck with a 2 mass, okay, that's going to be the 12, and a 5 for 17 for the bolt. And then compared to the bolt, which is going to be 10, all right, and then the 12 for the half mass twice the distance. So these numbers don't equal each other, and that's going to be a big problem. I mean, it's 30% difference in the number, so to speak. So you're not really moving the full mass. You can't have hunks of weight inside your lever and then say, I'm doing a balanced equation, because these hunks of mass are individual hunks of mass, just like on a wheel. There's a big difference between putting the mass here and putting the mass out here on the wheel. So if I make a wheel and I rotate it, right, this weighs more than this if it's the same mass. This one will weigh more than this one because it's going to have to go a faster velocity with each rotation. The arrow is going to be bigger, all right? And the same thing is happening here. So you can't use bolts to attach your weights because the bolts are a weight. So that's a flaw in your experiment, kind of an obvious defect in your experiment. Besides the fact that it's, like I said, there's no quick release and your control isn't very controlled. So leave us play the junk.
3/4 pound, 12 ounces, and these two make about half the difference, or half the weight, 6 ounces. These.
It really shouldn't be about. I mean, you do technically have to get these things really quite precise to actually be doing the experiment fairly. Because all I have to do is change this position by a millimeter, and I'm going to change the rate at which it oscillates. So you're really cheating the precision needed to do these experiments and have them mean something.
You can place these at 2 distances or 1 distance.
Speed it up a hair. Well, then you won't see it.
This setup at the moment is to show that they're roughly in sync. It's not perfect, but these 2 springs of equal force.
So they're obviously not perfect. That's correct. One of them seems to be more freely moving, and the oscillations last longer than the other one. So there appears to be more friction in one than the other.
Or putting the same amount of energy into both levers.
So that's
And
the
it
other
should-
part. He seems to push it up a bit higher when he does the later experiments. So for some reason, this experiment, he's not pushing it as high. So he's not putting as much force into the experiment for whatever reason, right?
accelerate at the same velocity. Well, they do pretty much. Good enough to show.
So that was a little bit better in terms of the amount of energy he put in, but you can see it's only 3 or 4 oscillations. The spring just gets in the way on the back cycle. It doesn't really show anything. You really can't make a good oscillator when your spring isn't going to expand and then be compressed. It's just going to get in the way. So this is not a very well thought out experiment.
One of them's a bit better than the other, but it's very difficult to get it perfect when you do.
Yeah, exactly. So you didn't get it perfect. It doesn't match. Okay, so you've already got a bit of error, eccentricity in there that shouldn't be there. And now you're going to do an experiment and say, well, that eccentricity isn't going to get exaggerated when I change the positions of the masses. When, of course, any defect that exists in your balance is now going to be exaggerated because you're going to put it into a higher, the standards are going to be higher in terms of any influence that's going to change the oscillating rate.
You know, garage tinkering, you need some facilities and equipment to get it perfect, but it's good enough to show.
Oh yeah, no, you're saying it's good enough to show. What I'm saying is it's good enough to make noise on the subjects. You're just doing another noise experiment. You don't have a theory that you can explain. You're basically doing experiments attempting to prove there's no conservation of momentum, but you'll provide no explanation for why there would be a difference, where the extra energy went, where the missing energy went, where the missing momentum went. And it's a pretty bold assertion. You're going to prove there's no conservation of momentum. And so you're doing this bold assertion with this rickety pile of shit. And somebody's supposed to be really impressed with what you're doing? No, what people should say is, well, geez, you're just adding noise. You're just like any one of those free energy nuts who makes some rickety machine and then gets it to run for 17 seconds longer or something and then says, see, I've perfected it.
Difference. They're roughly in sync.
Except for the one that just keeps going and the other one stopped, indicating one of them obviously has a lot more damping in it than the other one has. Whether it's the spring being stiffer or whether it's the bearing being stiffer, who knows? But obviously one is obviously damping sooner.
Okay, well
The energy's being pulled out of one more than the other.
let's see now if there is any difference. Take that weight off.
So you can see there's substantial bolts he has bolted into this mechanism. So it's technically not at all at balance. It's got these big hunks of mass in these specific locations. Any mass he adds at any other location has to be divided into those masses in those positions. So they are diluting any change. So you really can't do a 50-50 exchange. I mean, you can't do a 1/2 exchange. Twice the distance for half the mass, because you won't be reducing. You won't be eliminating the 2 mass, so to speak, from this location because the bolt's still there.
And put half weight now at twice the distance from the pivot point. And
Right, so it's not really a half weight because you have to add it to the bolt's weight. So you have a very light, just a bolt here, say 5 ounces, and then you have a bolt plus 5 ounces out here. So you've really changed the mathematics of the weight exchange, and so you're really not doing a 2-to-1 exchange anymore because the bolts are diluting that. So you really have this in the wrong position because based on the center of mass, it should be either a little closer or a little further away. I guess it should be a little further away. But that's just a guess off the top of my head.
you can see that overall the force is the same on the spring because although it's half the weight, it's twice the difference.
Yeah, but it's not half the weight because you still have this piece of the last weight is still there. And this piece out here weighs more. This bolt weighs twice as much. By the lever's standard, this bolt weighs 5, this bolt weighs 10. So you've clearly already got a very unbalanced circumstance.
Principal leverage. Okay. I don't know if you can see, but one of them is accelerating faster than the other.
And it's accelerating higher than the other. Okay, so go ahead and figure out what that means. It's clearly arcing higher. So if it's going slower and yet it's going higher, then it must be just how the time of the force is being distributed, but it doesn't make much sense, frankly. You have a hard time explaining why that momentum difference and why less momentum travels further. That wouldn't make much sense either.
And it happens to be the back one.
Yeah, that stops a lot sooner, and then you just switch them and they'll do the same thing, blah, 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 blah.
This one is moving faster than this one, because this one has greater inertia.
So he keeps saying it. This one has greater inertia. Where? Where is your physics video? Can you link me to a video where they explain how a half mass twice the distance has greater inertia? Who says so? What physicist said so? Who discovered this as a truth? Where was this written as a truth? What physics are you defending except your own? This is your own statement about the reality. It isn't anybody else's, because you can't link me to anybody else who's saying there's more inertia. There isn't more inertia. You fix the inertia imbalance by making it half the mass. By making it half the mass, you got rid of any inertia difference. They now have the same inertia.
Being that the weight's further out, even though it's only half the weight now.
So it's technically not half the weight, because the bolt actually weighs twice as much as the bolt in this other position.
Amazing.
So again, if you played this out, it's, what is it, 4 to 5 or something? One oscillates 4 times in the same amount of time as the other one oscillates 5, something like that. I mean, he doesn't bother doing any slow motion thing, doesn't bother counting, doesn't bother with any of that. He just says somehow this proves something. Everybody should just be so impressed with his proof. And it's not a proof of anything useful, because it's not a well thought out experiment, and it has no theoretical backing at all. He has no theory he's explaining. He's just saying, that has more inertia because I said so. Not because physics says so, not because an equation says so. There's no equation that says so. There's no anything that says there's more inertia out there.
Interestingly, they do about the same amount of oscillations, the same distance travelled. So it's the same amount of energy.
Well, it says you. I mean, it just appears to me that it's kind of obvious that one of them goes further than the other, but whatever.
Both, actually. But this front...
So it seems pretty weak, okay? It just seems like when the two masses on there, he's doing less, pushing. Because it seems like a lot less of an oscillator. Seems to die much quicker. I thought he would put him on the other one, but let's see, he'll do it this way again, and then he'll finally switch it.
This one is slower oscillating.
Yeah, well, that one you shoot. Yeah, well, that you can see where he started the back one first. So again, that's the big failure here. He didn't pull it away evenly. So the absence of a quick or even release here is a huge defect also. But the fact that he hasn't figured out these masses aren't the same. 5 ounces here of mass and 5 ounces of mass out here do not weigh the same.
Because of its greater inertia. Do it both ways, actually. It's an oscillator, isn't it? Much slower. Just swap them over.
So whatever he's doing, this is basically a catapult. This really isn't a balance. It really doesn't have anything to do with the argument I've been making from the beginning. that you'd have to conserve the momentum. The smaller, lighter object further out will, the more perfect lever, will in fact move at twice the velocity because it's obligated to do so. Professor Lewin would tell you it has to, and I certainly would argue it has to.
And the one that's there. Now the back one is going slower now, because that's got the more inertia.
Yeah, well, I guess we could do some of that frame by frame and see what we can see in YouTube here. Alright, so let's wait for him to restart it.
The back one is going slower now.
Alright, so we'll just jump through it as quickly as possible. So let's see, the back one is behind right now, yes. Okay, they almost hit the top at the same time, but yeah, one of them's reversing direction slower. And they're almost meeting again. Okay, the other one was on its way up when the other one was on the way down. So they're still less than an oscillation apart. So after 2 oscillations, there's still less than a full oscillation between them. So one of them's just a bit behind. And it gets more and more eccentric as you go further, but it's visually interesting, but it doesn't mean anything. Okay, if I did these for 10 oscillations or 5 oscillations, and I got some kind of numbers for how many seconds it is for the full oscillation, I'm going to get a number like 22 for one and 19 for the other. It's not going to be a huge, giant deviation, and it's certainly going to be a deviation well within the range of saying, well, you screwed up somehow. And obviously the big screw up is not recognizing that these bolts are breaking the center of mass of the masses you're putting on the lever. It's changing the positions you need to place the masses at to have your 50-50, your 2-to-1 relationship. You can't make your 2-to-1 relationship with these extra hunks of mass on the lever.
Because that's got the more inertia.
So he just keeps saying the word inertia, inertia, but we have absolutely no explanation for what this inertia is and why the lighter thing has more of it. So no explanation, no theory, no video link to any explanation for why there would be more inertia in the lighter object.
Hope you like that. I'll see you in the next one.
Yeah, whatever. Crap. More crap. Noise making crap. Alright, so we made a second video I haven't seen yet, so might as well see what the hell that crap is. I guess I could just move this up and then I can see it, and then you can see part of it anyway. See if there's anything relevant being chatted about. Alright, see how the chatters can do. Nice to see you again. Hello Gary, I checked and Ian Gosling made a new video directed to you. Yes, and more useless drivel. He hasn't done anything to respond to a single argument I have made. So he responds to nothing I say. So when I say gravity is 9.8 meters per second, and they actually say per second, why do you think it's per meter? Why do you think it's per foot? Why do you think it's some other way that you get 9.8 worth of energy? You only get the 9.8 in a second, and then you have to wait another second to get another 9.8. Respond to that point. Yeah. Respond to the point that if it goes 4 times higher in gravity, it does so in twice the time. And it's only going twice the velocity. And if I let it fall on a scale from 4 times the distance, it'll only weigh twice as much. Will you respond to any of those points? Of course not. He's such a duplicitous lying sack of scummy shit to think I'm obligated to point out the obvious flaws in his nonsense experiments, and yet he has no obligation to theoretically explain how he can violate conservation of momentum. That it's not a big deal. That somehow everybody's done it all the time. Everybody already knows there's no conservation of momentum. Yeah, that's what he's saying. He's basically arrogantly saying that somehow it's a known fact that there is no conservation of momentum theory. You know, that's what him and Brozo think. That somehow all the physicists, even though they say you must conserve the momentum, they don't really believe it. Alright. Have you seen the video I sent you of the experiment? Yes, it's a video I'd already seen. I'm trying to think what exactly it was about. But it really doesn't get to any point. Yeah, he doesn't do any measurements. Okay, so he uses a platform to basically shoot a cannon. You know what I mean? So you're shooting a cannon off a movable platform. So it's the opposite of a ballistic pendulum, in the sense that you're seeing how much the gun moves, rather than seeing how far how much energy is in the propelled object. And clearly, the heavier the object you propel or shoot, the more you move away. And that just has to do with the fucking math equation. I mean, there's a math equation, and obviously the heavier mass is going to win in most circumstances. All right, but anyway, so it's not useless. I mean, I just happens that I already had seen it like a week and a half ago. I saw that video. Thought it was interesting, but like I said, he didn't do any. There was nothing qualitative in it. He didn't measure anything. All right. Will you be open to covering my? What are you doing? Why do you have to keep doing this? Will you be open to covering my Ephelis-based shadow, the hedgehog animation? I don't even know what you're talking about. It's not for this channel. This channel is about science. Okay, so it's not about some other subject. So I'll just time you out. Thank you. Terminal velocity. What does that have to do with it? We're dropping things very slowly from very limited heights. There's no terminal velocity involved. All right. I mean, when a thing is dropped, say, 1 kilogram, it reaches a terminal velocity. Yeah, it does after about 10 seconds, 15 seconds. It takes a lot of time. Do it don't multiply the weight. Do it doesn't multiply the weight. So just more rubbish. Obviously, atmosphere changes, okay, how fast something can go. It changes how fast the space shuttle can go. It changes how fast a lot of things can go. That's why asteroids burn up in the atmosphere, because they're basically not allowed to go as fast as they want. The atmosphere gets in the way. So yeah, when I say 4 times higher, I'm talking about on the moon or something, okay? As a perfect example, but frankly, in light atmosphere with limited speed, terminal velocity is irrelevant. The air resistance isn't going to change anything very much. Now, if you're comparing a feather to a lead brick, it's going to show up and really reveal itself. But if you're dropping a ball bearing and a 5-ton car, they're going to fall at the same rate, and the air resistance is going to have a minor effect when you're dropping at 10 feet. So, not do, sorry. I don't know what that even means. So, not do. Not do. Not do it doesn't multiply. It doesn't fix that sentence, sorry. No point in fixing your spelling badly. So, do it. Oh, so do it? I don't know. No, that wouldn't work either. I don't know where I'm supposed to put the so. You should just rewrite the damn sentence correctly. But whatever. Who cares? It's not relevant. People just aren't very smart. I'm sorry. People really aren't very smart. I mean, I'm just saying, a tabletop lever, air resistance isn't going to be a big issue.
Hello, this is primarily for Gary.
Yeah, shove it up your ass, you fucking creepy piece of crud. I mean, fuck you. Fuck you. Should I give you instructions on to properly wipe your ass? I'm sure you don't know how to wipe your ass. Okay, you probably don't know how to do an awful lot of things. Should I explain it to you? You probably have pretty skanky foreskin, I'll link you to some instructional videos on how to properly maintain. Fucking cunt.
Science.
What a piece of shit.
But if it can help any younger viewers,
Oh yeah, so if I can fuck up anybody else and make them think velocity is a squareable function, that somehow I can create a velocity volume. Yeah, a volume of velocity. So something that's clearly the most purely linear thing you can find, a velocity, he's going to try to turn it into a three-dimensional object.
With them simple starting off in
Well,
maths,
two-dimensional.
all well and good.
Fuck you, fuck you, fuck
Now,
you.
I've got you a nice sheet of clear paper, Gary. You was getting a bit confused because I was using squared paper, wasn't I?
Oh, God. You know, it's just so stupid. Yeah, you were using paper that already has nice grid lines on it. And all you had to do was emphasize those. They help you draw a nice straight line, so it's very useful. And what you did was put the number 2 in the middle of the object as if it was 2. This was a 2 line. And this was a 2 line. When what you meant was, this is a 2 line, and this is a 2 line. That the whole line was a 2. So yeah, you didn't draw it in any kind of rational way. So yeah, I found it a little bit confusing. But it's totally fucking irrelevant, because I've told you the whole point of you sitting there multiplying force times, okay, how much it moves the spring is irrational. It's not a number that could mean anything to anybody rational. Nobody would do that. That's like multiplying the weight times the deflection in the spring. What sense would that make? It makes no sense at all. You might as well just say, I'm going to square the weight, or I'm going to square the movement of the spring, because it guarantees that the two effects, the cause and the effect, will be exactly the same. That's Euler's law and such.
So I've got you a nice sheet of clear paper. Now let's say the idea is we want to find the area of this triangle.
You want to. I don't want to. I'm saying it's mass times velocity. Those are two causes. Those are two things, ingredients that go into something. A mass ingredient, a velocity ingredient. They aren't the final outcome. So they can tell you a final outcome because you're multiplying two different things. You're not multiplying two same things. The velocity doesn't change the mass. The mass doesn't change the velocity. They're independent features. They can be multiplied. But you cannot multiply causes times effects and say, I'm doing something rational. Because you're not.
Why? I don't know why. Lots of reasons why you might want to represent it as an area, a number. Get a number for the area that it encompasses.
There is no area. It doesn't
we can see that
encompass an
this
area.
triangle is what's called a right triangle. It's got a 90-degree corner. And you can see that if we extended the sides, we'd make a square. As the length of the base and the height.
Yeah, that's multiplication, the square.
You know. And that once we've got a square,
Well, the rectangle.
we can draw that. We can draw that square on there. We can, then we'd have this square. Well, how do we find the area of a square? Well, we get a thing called a ruler.
We already know this. Okay, so I don't. What the hell is this video? Is he really just going to sit there and say, "Look, it's like multiplying 5 of these things going horizontally, okay, and you just multiply times 5 of them vertically," or some kind of crap like that? Yeah, duh. I mean, what is this shit? It's just so obnoxious, a waste of everyone's fucking time. And look, he did it again. He put the 2 there.
Now, if we measured this line up the side, I don't have to labour the point too much, do I, Gary? I mean,
well, you really should labour the point in the sense that, when people do these kind of schematic kind of drawings, drafting kind of drawings, they usually put a line here and a line through here and point out, this is what I'm saying is a 2. Okay, I'm not saying this location is 2. I'm saying this whole line is 2. But you couldn't even manage that. I mean, there are rules for schematic drawings, and if everybody did it this slop-ass way, okay, there'd be people making lots of mistakes. There'd be lots of bridges that wouldn't be working too well.
that's another 2. Now you've measured the two sides. That's all you need to find the area of this square. You then times 2 times 2. You combine the two sides, you multiply them. 2 times 2, what's the answer? Well, I make it 4. I hope it's right.
Alright, fuck it. You know, there's no point in watching this shit. See if there's any comments. Do I detect a hint of sarcasm there, Ian? Yeah, whatever. This is a waste of everyone's fucking goddamn time. So instead of answering my questions, why do they say 9.8 meters per second when it's 9.8 meters per foot? Why do they say it? Where in physics, where in the annals of physics lectures can I go see the lecture where they tell you the 1.4 thing? Okay, that momentum isn't conserved and that 1.4 is conserved. Where is that lecture? You weasel. Oh, what a piece of shit to play these stupid fucking games. So we'll see what the brozo said here. Alright, another great demonstration. So it's right in line with all these other fart noises that these people want to make and say, look, I just did a great experiment. When no, all you did was make a smell. Okay, you made a stink. You made a mess. You didn't do science any favor by doing your shitty, rickety, cruddy, unthought out, imprecise experiment. That's not what the world needs, is more imprecise experiments. So fuck you for contributing to the noise. Alright, the real reason Gary won't try any of these simple things himself. So again, you're proving they're not so simple because you're doing them so badly. So this is coming from the asshole, right, who did a simple experiment. I mean, all he's going to do is measure two things hitting a spring. Right, and the idea is one's going half the mass, twice the speed. The other one's twice the mass, half the speed. And I think I said that right. Well, regardless, you get the inverse mass to velocity ratios. And they're just going to hit a spring and you're just going to measure how far they compress the spring, right? So momentum says the answer should be 12. Kinetic energy says the answer should be 16. And what does the brozo get for an answer? 14. And he tells us how these are all great experiments and everybody should be doing them. Because it's really great to get completely erroneous nonsense answers. Nonsense answers add so much value to this whole process. I mean, how could we live without these nonsense answers to the question? Complete nonsense answer. All right. Just like these stupid fucking inertia spinning lever experiments where they don't do anything precise and they just say, look, it spins at a different rate. It doesn't spin consistent with kinetic energy formula. And so, yes, it's not spinning consistent with momentum. So which one are you proving? You're not proving anything except, gee, I got an erroneous experimental result that makes absolutely zero sense to anyone's physics theory. No one in the conversation has a physics theory consistent with your outcome. So what should be a suspect? Should your experiment be suspect? Or should everybody concede that, yeah, now there's a right answer here. It's either black or white. It's not pink. Okay. Isn't the lack of space, wood, or wood? I wouldn't do that. Or springs or weights. It's lack of incentive. So again, it's just a lie. So he likes to making up fake stories. This little, guy who likes to play with. He has his email address is like Papa Pics, something like that. What is that about? So he wants pictures and he's doing his pop-up pictures or something? I mean, it's all kind of, ooh, isn't that a little bit creepy? Sounds a little bit really creepy to me. Like, well, who's doing that kind of stuff? Who calls themselves Papa? What is that? That's a little creepy. So let's make up a story. So I made it clear, I don't have any fucking goddamn space. It's just a fucking goddamn fact. All right, and yeah, so if you don't have a decent place to work and you're in fact going to try to do decent experiments, it's really not a great idea. I mean, I demonstrated by the very fact that I had to do the air track outdoors, for fuck's sake. I mean, this is just such bullshit that this lying little weasel can make up this fake crap stories anytime he fucking feels like it. I mean, he's just such a disgusting little lying twerp. Anyway. Imagine you were Gary, desperately trying to make them oscillate roughly the same. So, again, this accusation that I'm trying to do anything. I showed the lever perfectly oscillating with a 4-to-1 ratio on the lever. The balance. The one object was oscillating at 4 times the speed of the 4-mass object. Momentum was perfectly conserved. And I asked the simple question, where's the evidence of your kinetic energy theory in the oscillator? Do you understand the oscillator cannot make more energy on one side than the other side of the oscillator? The whole point of an oscillator is like exchanging a potato between two people or something. The energy has to move from one side to the other side. All of the energy. Anyway. How would you do it? I don't think any of us could. I suppose, so he's saying it's just really hard. So yes, of course you can't. You can't get any right answers for any question that it could be asked. I suppose you could hide weights inside the wood. Well, isn't that what the Falwell guy did? Maybe we should go watch his wacky video. So right in the description he says, I have magnets in this pole and I have weights in the stick. And he has all this bullshit, and you're saying, well, what value could this possibly be? What kind of fucking bizarre experiment is he doing where he has magnets and, you know, some sort of steel rod inside of a carbon fiber rod? You understand why he's doing that experiment, whatever the fuck it shows? I mean, you people are amazing, duplicitous, lying sacks of shit. But then you could swap modes in a live, continuous footage kind of scenario. Why don't you do any of that? And I'm not even sure whether even that would work. So this is a guy who, frankly, quite obviously has done a ton of experiments he never showed us. Okay, he videotaped them, never showed us the experiments. Just a fact. He's got crap all over the place, all kinds of experiments he did, never showed anybody. I'm not motivated to try, even though someone once suggested I do it to play a joke on Gary. I don't even know what joke it would be. I just, again, shoot the mass thing. I told you already, your billiard ball experiment was, you know, in a sense, pretty reasonable. Just do that over and over again, different ways, and see if you can fuck up the results. See if you can make the results turn out to your 1.4 bullshit. Go ahead, try to force it to do that. Oh yeah, that's what he already did, okay? And he was going to show us that video until I already called him out and said, yeah, he's going to fix it so it comes out his way. And that's why he didn't post it. So the video he was going to post as soon as possible, right? The video he was going to show us that demonstrates how, yeah, the billiard balls don't, you know, momentum isn't conserved. Where is that fucking liar? You sack of shit, lying sack of shit. You promised the damn video. You were going to make the damn video. You were going to show the damn video. You had the proof. You were going to prove it to everybody. Why don't you get on with it already, fucking liar? Oh, he's just such a fucking piece of shit. Then reveal the cheat, how I managed to achieve his prediction. Yes, well, again, my prediction is your results will always be shitty and or an overt cheat. That is, something's going to be bent, crooked, something's going to be uphill. You're going to do the experiment in some stupid, moronic way to force it to come out the way you want it to, and that's the only film we're ever going to see. All right, but then he would have just cause to accuse me of cheating, so the joke would backfire. Yeah, well, it's already backfired. Okay. Go ahead, show us your lever pushing the billiard ball experiment. Show us the better version you did that was right on 1.4, exactly as you would predict. Show us that it isn't a fucking cheat. Alright, and I still don't know how I'm supposed to achieve Gary's outcome even by cheating. So again, you already say you have your cheat experiment in the sense that I'm going to say, yeah, it's a cheat. Okay, show me your 1.4 proof. Show it to me. Alright, he doesn't know either. Penn and Teller might. Yeah, you're the one playing the smoke and mirror games where you give us 4 seconds of video. Remember the air track video where you gave us 4 seconds of video of the interaction? Yeah. It's so much easier for him to be in denial, blaming weight on the bearings. Well, frankly, where the energy is going to go can only be through friction. So you just look for the sources of friction because those are the only places. If you're going to say half the energy disappeared somewhere, you're going to have to account for it somewhere, fuckhead. So again, keep doing your I'm going to prove there's no conservation of momentum experiments, and I'll keep asserting that every one of them is a cheat, okay? But you who don't understand how the experiment works, because you're not going to explain where the fucking energy went, moron. Okay, I would love to know how much weight it really would take on our various bearings to affect the speed so dramatically. So he thinks this was a dramatic effect, when clearly it's visually interesting, but it's not very dramatic. All right, the lag is just a few seconds over 20 seconds. But whatever. I dare say we could deliberately add heavy lead weight right over the fulcrum for a faster one to show it doesn't slow down. I wonder. So he doesn't think weight causes more friction, regardless of any circumstance. The more weight, the more friction. We don't make perfect bearings. The more weight, the more friction. The more energy you're going to lose to friction. It's just a fact. Obviously, the more weight, the more energy you have to have in the system for it to move at all. So, I mean, this is just such, again, he doesn't have any physics theory. He's operating with no understanding of any physical mechanist kind of understanding of physics. It's just this, he has some vague notion of these weird principles, and that's all he has. He doesn't have any idea. And here he's perfectly willing to accept the idea that there's no conservation of momentum when every single physicist says there is. So, I mean, how can you make any sense out of that? Just show me the video where the physicist says, no, you don't have to conserve momentum. Show me that video. That would be very persuasive. A physicist saying there's no conservation of momentum? Yes, it'd be a very interesting video. Show it to me. What a dumb fuck. Lying sack of stinking, rotten, smelly, cruddy, fucking pustulous shit. Alright, so I'll show you this bizarre video by this Falwell guy. Just completely there's just no way to account for it at all. I mean, what the fuck are you doing? Alright, so there's no sound, so you can just watch this, I guess, a little bit of this. So he turns the wing nut, and all of a sudden things, look at it, spinning. So we don't know what he's doing exactly. It looks like there's just a wing nut. He turned the wing nut a little bit, and all of a sudden you have all this rotation somehow. Somehow all this energy got into this system somehow. Is that what, does that make any sense to you? No, of course it doesn't make any sense. What the fuck was that? All right, so he says, in this simple lever demonstration, this isn't a simple lever. No levers do that. I can't just turn the wing nut on a bearing, and all of a sudden the lever goes spinning around and around. Alright, so here's the real story. The lever is a carbon fiber rod weighing just 36 grams. It is pivoted by a metal rod running through the center of the lever. So I guess he has a hole in the carbon rod, then mounted to 4 sealed cartridge bearings. Then mounted on 4 sealed cartridge bearings. I don't know why there'd be 4 bearings, but whatever. At each end of the lever there are 2 magnets, one above and one below the center line. Okay. Each magnet weighs just 2 grams, so the combined weight of 4 grams balances the lever at each end. So he's just saying there's 2 magnets on the end of the stick. And somehow, by just turning the wing nut, he made it spin. I apply a turning force at the pivot point. Well, how are you applying this turning force? I mean, you won't show us how you're doing that, okay? And obviously you're doing it inconsistently, like you're not putting the same force in, okay, of various amounts, and let the lever come to rest, verifying if its configuration there are any oscillations. So again, you're just wondering, what the fuck is he talking about? What is he trying to prove here? I mean, of course there has to be an oscillation, at least one oscillation. So this is where it got stuck, okay? And it got stuck because the friction in the bearing always ends up being more than the energy to force it back into its configuration, especially when the weights are so much lighter than the actual lever. So the lever's 36 grams and the magnets only weigh, what did he say? 4 grams. So the lever weighs a lot more than the masses he put on them. So he really hasn't done the lever any. The lever doesn't have much ability to see that there's a little tiny bit of mass below and above the center line of the fulcrum. So he just has a tiny bit of mass. And that's the mass you need to create a balance. So this is just so useless. So anyway. Just rubbish. This doesn't, so they'll go to all this trouble, but they won't just sit there and, Ian Gosling had the experiment, right? He has a spring and then just a rod to keep the stuff from flying all over the place, and he just pushes down the spring and launches the weight. So launch a 2 mass and mark where it goes, and then put a half mass on with the same compression, and if it goes 4 times as high, your theory's in the toilet. You're done. Because that'll be twice the momentum. Twice the force of gravity will be opposed for a half mass. Alright, so nice setup, love it. Let's see, I would call a seesaw because see again, so they don't even know what a scale is. It's a scale, but whatever. Let's see, doesn't seem to want to oscillate. Yeah, because the lever weighs so much more than the weights. That's why it doesn't want to oscillate. Let's see. I challenged Toady. So this is where he insults Toady some more. So this is kind of funny. So yeah, I should read just so Toady understands what he asked for. Now he's getting it. Oh yeah, I'll be nice to these assholes. All right. I challenged Toady to balance a non-bendy lever on a razor's edge and see how long his phone battery lasts trying to video it in a continuous attempt. So again, it just has to do with how you place the mass on the lever. So if the masses are above or below the center of the fulcrum, you're kind of guaranteed to create an oscillator. I mean, that's the factual observation. And it's even more ideally is you want to dangle the weight so it can always stay perpendicular to the gravity. So in a sense, it's always applying the same weight. If I put this pen on a string and I hold the string, it doesn't matter where I go with the string. It'll always produce exactly the same weight. Where if I put it on a stick or a bar, I can end up changing its weight because I'm changing its position in the gravity. I'm changing its angle. Okay, so I'm forcing it to rotate at different circumferences from the fulcrum. And that means that you're changing its weight, essentially. Well, anyway, we won't bother reading this slop, but it's just slop. Oh, these people, just insufferable slop. Alright, so let's see if these people commenters can say anything. If not, maybe I'll just call it a day again. Alright, let's see. I'm just wondering if the measurements... Oh, okay, wait a minute. Let's see. When the thing, 1 kilogram, it reaches to... Okay, so we did that already. It doesn't multiply the weight. So it doesn't multiply the weight. 4 times the distance doubles the weight. I mean, I did that experiment. Okay, you lift something 4 times the distance. So if I drop something from 1 centimeter, it weighs whatever. I drop it from 4 centimeters, it weighs exactly twice. I drop it from 4 centimeters, and it weighs something. And I drop from 8 centimeters, it weighs 16 centimeters, it weighs twice. So gravity is always doing the 4-to-1 thing. Double the speed and you you double the weight, and you double the speed by going 4 times the distance. You double the momentum by going 4 times the distance in gravity, because again, gravity's time dependent, and as your velocity increases, the amount of energy you're getting per foot decreases. So you fall 10 feet and you only get 1 unit of energy. The first foot, you get a unit of energy. Okay, the next 3 feet, you only get 1 unit of energy. The next 5 feet, you only get 1 unit of energy. The next 7 feet, you only get 1 unit of energy. All right. Let's see. But I understand you're more focused on quantum physics. I don't even know what that was. Let's see. I'm just wondering if the measurement should be taken at the weight's terminal velocity. There's no terminal velocity in these experiments. It's not an issue. Air drag is not really an issue when you're dropping objects or moving levers through space. It's a very minor cause of any differences in the experimental results. If you did the damn thing in a vacuum, you're not going to get hugely different results. Oh, shit. But I understand you're more focused on quantum physics. I don't even know why you're saying that, but whatever. I'm focused on the fact that quantum physics is a pile of shit. 1/2 mv squared is not quantum physics. Pero did a well, in a sense it is, right? Because all the bullshit, it is the source of, Einstein's, bent light bullshit. It is the source of all particle physics, is based on 1/2 mv squared being a definition of how much energy is in a system, and therefore they have to keep inventing particles, because every time they move something faster, they give it more energy, fake energy, and then they have to account for the extra fake energy, so they create some new particle. Pero did a similar thing. Stephen posted it. Yeah, obviously it's an old piece of shit, irrational per second video. There's no per second. There's just acceleration. Acceleration is not a squared term. Acceleration is just like you go 60 miles an hour and I accelerate you to 90 miles an hour. I gave you 30 extra miles per hour. I didn't give you 30 miles per hour per second. I just gave you an extra 30 miles per hour. Let's see, Gary, you already won the argument. It's clear that these people are doing all of this for their own amusement. Well, they're evading every bit of conversation that has anything to do with explaining why they believe what they believe. They can't show us any background resources explaining why other physicists say so, why it's reasonable, why it makes sense. Nothing. And they're just asserting it. So yeah, it's like they have never read the Bible and they're just defending the idea of a Messiah or something. I mean, it's just so disconnected. They can't connect it to any real physics. So they're trying to tell me that I'm being anti-science, and yet they can't even describe the science that I'm opposing. They can't even explain it. These people aren't taking the subject seriously. I am Brozo, the mindless marvels are a joke. Yeah, well, frankly, you can say so, but I have to demonstrate so. And the joke is, all I would wish people to appreciate is they never do what I request. Every experiment I say to do, they don't do it the way I said it. And every single drawing I've made, and every time I've said draw a lever and explain how it works, explain how you can violate conservation of momentum, explain how you believe that's okay. You don't have to account for where you lost all the energy. All right. Is friction a force, or does it rather steal force? Well, exactly. So that's a simple enough question, and clearly physics has no clue. It clearly is just a place that draws your force away. You call it friction, right? When it's something else taking your force, you call it friction. When something else is giving you force, you call it you're getting energy. But it's just an exchange. And so obviously when we exchange with the Earth, we lose the exchange, okay? The Earth is a huge ground. If I'm electricity, right, the Earth is going to suck all of whatever I have. If I have 1,000,000 volts, it's going to take it all, okay, because the Earth is greedy. But the fact that I gave it my voltage does not mean that it doesn't have it. Of course it has it, okay, and I've lost it. But that's all that took place. We exchanged, all right? There was no counter force. The ground didn't do a counter electricity. It didn't create any counter electricity. It just took what I had. All right, the friction is a force, or does it rather steal force? Yes, steal force is a much better way to think of it. It's just an exchange, and the bigger object usually wins the exchange. The longer you're in contact with something, the more likely you're going to become its temperature, so to speak. Right? You're going to become a common temperature. But you can't become a common temperature if it's 70 degrees and you're 50 degrees and it weighs 10 million times more than you. Then all you're going to do is change its degree a little tiny bit. You're going to become it. All right? It's not going to become you. All right, eliminating friction from the experiments would be the difficult thing. Well, part of these experiments are dependent on friction because you need something to pull the energy out of the system so you can measure it. So the very idea that we eliminate friction and I shoot something twice as fast in space, and then I use their equation where distance equals force, our energy, I'm going to get, if it's going twice as fast, it goes twice the distance, it's twice the force, right? There's no problem, right? Because obviously it's only in gravitational friction that I go 4 times the distance in the same time. And I won't do it in the same time, right? It's 4 times the distance in a measurement of time. It takes twice the time to go 4 times the distance. And the fact that it's only twice the time should tell them, oh, there's something wrong here. I'm going 4 times the distance, I'm doing 4 times the work, and yet I only did it in twice the time? Anyway. It's possible to make ferrofluid at home. Yeah, so whatever. I don't even know if that's true, frankly. Making those little tiny nano bits of iron oxide, I don't know if you can pulverize iron at home that well. Using that could reduce friction. How would ferrofluid reduce friction? That is just... Sorry, you're being a little wacky. Not directed at you, draft. I don't care who it's directed at. It's absolute nonsense. Ferrofluid is not a great lubricant. I mean, it's oil, okay, that it's in, but I just mean the iron oxide isn't going to help you any in terms of lubricating something. I think sometimes your explanations might sound complex, but really you're saying they're simpler or basic explanations. Yeah, of course. I'm saying the system is mechanical and it's not that hard to understand, and momentum is one of the easiest to understand things there could be. The idea of mass and velocity. The very idea that right now you have momentum into the earth. The fact is, gravity is acting on you. It's giving you a velocity, and unfortunately you can't see it because the earth keeps pushing you back to where you were. It keeps replacing you back, putting you back, putting you back, putting you back. So you can't see yourself falling, but you're falling nonetheless. And that's what a scale shows. A scale shows your momentum. Your weight is in fact showing you a momentum. And if I gave you a momentum in a direction sideways running into this scale, I could find a perfect speed that you go where you end up weighing on the scale exactly your weight in gravity. I could duplicate the speed that gravity is pushing you into the earth. Okay, what would be the ideal setup? Well, like I said, you don't even need ideal. Like I said, I already pointed out, Brozo had the experiment. He shot billiard ball, like a half-cut billiard ball and a regular-sized billiard ball. Maybe there's better things to push. And he made a little spring lever and shot them. And clearly the experiment came out 2-1, I would argue, really damn close. 1911. Okay, the twice as massive object went half the speed. The half-mass object went twice the speed. That's what the experiment pretty much demonstrated pretty conclusively. But regardless, I'm just saying that's the experiment. That's a good experiment. Do that one really good, and that's pretty much going to tell you the truth, okay? Because there'll be no sign of kinetic energy, and it'll perfectly demonstrate conservation of momentum. The other experiment is the stupid Ian Gosling guy has his little springs with his weights. Well, just take the weight, push it down a certain amount, a 2 mass, and then release it and see how high it goes. And then just push it to exactly the same spring compression and put half the mass there and see if it goes 4 times higher. If it goes 4 times higher, achieving twice the velocity, will perfectly conserve the momentum, and we'll know, okay, that kinetic energy is horseshit. I mean, I think the lever argument is decisive, frankly, just because that's the whole point of levers. The whole advantage they provide is they do a direct conversion between one momentum and another momentum. You can change the mass to velocity ratio. I can take something going really heavy, slowly on one side, and I can make something fast and light on the other side, or vice versa. It's been proving for thousands of years that there is conservation of momentum, and there is no evidence of anything called kinetic 1/2 mv squared energy. It doesn't exist. It's a fallacy, a fable, a fake, a phony. Absolute nonsense. I mean, look, the original, this started with a physics girl stupid video where she was doing a classic thing where you take a 5-ton train and then you drop an extra 5 tons on it, and now it's a 10-ton train and it loses exactly half its velocity. So this is an experiment that's been done tens of times, tons of ways. It always comes out this way. Okay, the 5-ton train going 10 miles an hour gets converted into a 10-ton train going 5 miles an hour. And the conversion is perfect, okay, in the sense that it's just a tiny bit of reduction in velocity. But let's understand what they're saying. By kinetic energy theory, you just lost 1/2 the energy from the system. You have half the energy of a 5-ton train, and yet you didn't lose any momentum. And they say we lost half the energy because we made sound and we bent things and we broke things and all kinds of disasters happened and houses burned down, all kinds of shit happened. No evidence of any of that shit happening. And you did all of that without using any momentum. So just think of the idea that you could possibly do anything called work. That is, you could create heat or movement or sound or do any of that, and you would never have to use any momentum to do it. How can you construct an experiment where you don't have to use any momentum and you can create all of that? That's impossible. That's nonsense. Did she nearly die? I don't know. I mean, she's still in the process of doing whatever it is she's doing, right? I don't want to say high maintenance bitch, but I'm just saying, whatever this long COVID thing is. I haven't seen any scientific data on it. I mean, she must have a blood pressure and blood work done and all that kind of stuff. I mean, what exactly is she missing? Or is it all just, psychological horseshit? And I'm not saying psychological horseshit isn't a big problem. I have a real problem with my psychology and keeping myself balanced and keeping myself functional. So I'm not saying that isn't a real disaster, but maybe that's all she's got is she's depressed. I don't know. Really depressed. Okay, has passed. I don't even know, or has passed. I don't even know what that means, but whatever. I think we know if she died of it, but whatever. Seems to me they're milking it. They're playing her old videos where she's all alive and perky, which seems really in poor taste. So the whole thing is just kind of, they actually did a video of her cutting her hair off because she can't, take care of herself anymore. And it was just so, it's like, what are they doing this? This is embarrassing. And it just seems like a plea for money. And yeah, I can understand they need money and all that kind of crap, but the whole thing is damn tacky, frankly. I'm sorry, it's just tacky. I'm sorry she's not healthy. I'm sorry she's in pain and all that crap. I feel very bad for all of that, blah, 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 blah. But the whole way it's been handled has been just tacky. Brozo's rich now, apparently, so maybe he can help Physics Girl out. Oh, very strange. The crap that goes on in the internet. It's a very, very strange place, the internet. My battery is ceasing to produce the required voltage to hook it up to the solar panel. Alright. Is bad science going overboard? I don't know what that means. I wonder how fake Sagan is doing. I don't know. I wonder how Snake Plisskenus is doing, your Lord and Savior. It is kind of irritating when people just disappear. I don't know why they do that. I mean, it seems a little bit rude, frankly, just because you should properly explain. Oh yeah, I'll be going for a while, you know, something, 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 you know, some kind of something. But blah blah blah. Yeah, we're not here to do stick-em days. I'm here doing physics. Let's try to stay on the proper subject. Thank you. But that is an interesting subject, just because it would have been interesting to see what you could have done in a physics conversation in Stickam. I mean, some kind of place where you could force people to answer your questions. Because that's the big missing ingredient in this debate, so to speak, is I have no one to debate. Nobody will answer any of my points. They won't address any of the subjects. They won't touch them. Leibniz was, in fact, a kook. He was a religious fanatic. He actually said to Newton about Newton's physics and Descartes, he called them two atheists. These were both religious nuts, Newton and Descartes, and he called them two atheists. He said their physics is two atheists. So this is not the guy you want to be the founder of your science. Momentum is not loss producing sound. Well, then you're an idiot. Sound is motion. It has to be created by something else's motion. I'm sorry. You think the world works in some other way, then something's motion has to be transferred to one place to another. Eddy currents have to be stored. Different things the momentum always has to be somewhere. Okay, and it can be in the form of chemical energy, which is the compression of atoms and their shape changes and different things, but it's always somewhere. And so you can play your little baby game and think momentum doesn't produce sound, but yes, it has to. Physical motion has to take place to move the atoms, so you're out of luck. And the fact is you have to move them at the speed of sound to actually make sound happen, where you can cause the reaction not to be diluted. You have to move something very fast, or the energy gets pushed in sideways directions. So when you're going through a substance, the idea is the faster you go through it, the more likely everything you hit will go forward. And the slower you go through, the more likely it'll get all kinds of angles, and you'll start losing all the energy to dissipation. So it's kind of an interesting argument that the speed at which something travels has a lot to do with how much deflection there is in the progression of that energy through a system. Frankly, I mean, I think this subject of kinetic energy is really important. You want to talk about sound, it's okay, but I'm just saying, I'm sorry, you're just wrong. Okay, and I don't know that you've done any research on it at all. But sound breaks up, slows down, air resistance. So again, more baby talk. It's different in different thicknesses of material. So it just depends on how dense the material you're going through changes the speed. But the function of sound, what it's actually doing, is transferring energy very efficiently through transferring it through the electrons. So it's taking advantage of the fact that that is a very straightforward poke, where cue ball hits cue ball hits cue ball hits cue ball, and it's not deflecting in any way. Where if you push things unevenly and at a slow speed, all the energy starts going sideways, as I pointed out. But whatever, believe whatever you want. I just don't know if it's worth arguing this crap. I'm not talking about wind, you fuckhead. You could also show experiments and debate on Google Hangouts, if it's still a thing. So why are you bringing up shit that you don't even know if it's a thing? Well, it's obviously not a thing, frankly. Do you see anybody doing that? It's obviously not a thing. You have to use some other server to allow you to do multiple people and all that kind of crap. So it's not a thing. And why the fuck would I use Discord, for fuck's sake? It doesn't provide any advantage at all. Oh, shit. God, you people really do. You're just trying to irritate me. Nathan Oakley, 1980, is a flat earther and would debate physics. Irich. What does that even mean? Why do I give a fuck about a flat earther? Why are you bringing it up in this video? Where have I indicated I give a shit about flat earth philosophy? It's just not true, okay, that the sound is being transferred by momentum. It doesn't mean that it has to change speed, as I just pointed out, because you could be hitting the electrons and transferring the motion to electrons. All right, and the fact is the electrons are in an atom, and the atom has to balance all of the other electrons, and so they end up moving at a consistent speed because they're essentially sharing it with each other. So there doesn't have to be any direct correlation between how fast you put in the energy and how fast the energy comes out. I mean, how much of it you actually transfer into the sound. I mean, let's realize that the sound moves in all directions, so something that makes sound ends up sending sound in all directions. So it's clearly sharing its energy with an awful lot of other pieces of matter. It was atheist because it was mechanical, fuckhead. Because Descartes was basically saying God doesn't need to exist, okay? The whole thing runs by itself. You start the engine and the whole thing just keeps running because the energy never dies. The energy in the universe has a history. Zillions of years, trillions, doesn't matter. The energy is always going somewhere. It's always someplace in the universe. It's never created, never destroyed. So all of the motion is forever motion. You can't stop it from having motion in it. And it doesn't need a God to run. That was the argument. That's why it was too atheist, is because it didn't need God to fix it. Anyway. Well, he's up for debate, but yes, I'm just going to block you. I mean, why the fuck do you think I would want to have a fucking debate with a goddamn flat earther? I'll put you in a timeout anyway. I mean, what the fuck? Are you fucking retarded? You don't see how that's a complete insult? I should debate a flat earther? Why the fuck would I do that? Why don't I just debate a religious kook on a physics channel? Why the fuck would I sit there and waste my time arguing with a compulsive liar? You have to be a compulsive liar to be a fucking flat earther. The evidence is so fucking overwhelming. I mean, why don't you just fucking do the earth a favor and drop dead? Your fascination with flat earthers is so inappropriate and nonsensical. Why don't you just say this to anybody else? Just go debate a retard. I know a retard who lives down the street, okay? He just eats his own earwax all day. Okay, go debate him. Fuck you. I should have just blocked you. God damn. What did I not insta block you? I'm just gonna block you. Fuck you. Fuck you. If you were transferring momentum to produce sound, then sound would slow down when within the same medium. Now, it's like a rope creates a certain amount of speed for the waves you put into the rope. Okay, it always tries to neutralize it into the mechanism you're pushing it into. So obviously the density or the stiffness of the material is going to decide how fast something's going to go in. And it's really not going to be about how fast the thing that's pushing is pushing. But the whole point of my argument is that that's how sound is created, is that you have to break a barrier. You have to break a speed barrier right over that little edge of going faster than the actual speed of the transmission speed of the electron. So you have to give the electron enough pressure to essentially jump from one atom to the next atom. And it's that barrier that defines how much energy is going to be transferred. And that's the efficiency of sound. Sound is taking advantage of a non-friction environment, essentially. There's no friction on the subatomic level, okay? There's no friction. Friction happens to the subatomic particles. The subatomic particles are friction. They are heat. So in a sense, you're guaranteeing that the heat will move in one direction. That's essentially what sound is. Sound is saying, I'm going to have heat travel in one specific little tiny path. There's no wave action required. And beyond the fact that obviously in the case of the atmosphere, the air pressure is pushing the atoms closer to each other than they would like to be, so therefore the atoms communicate with each other because they're being forced to be closer to each other than they would be if they could be in free space. But anyway. I mean, Brozo mocks the argument I make that sound is created by faster than sound motion. So you have to basically break the sound barrier. And you have things that that illustrate it pretty clearly. Our vocal cords, for example, okay, have a bunch of little fibers on them that end up vibrating really quickly. Okay, and then the whip is a really good example that you get that crack sound when you can make the tip of the whip break the sound barrier. So there's all kinds of indications that the fact is you need more energy in to get your wave out. Okay, but once you do it, the key point is that you've changed the motion from an environment where there's lots of potential for losses, that is stuff moving in the wrong direction or at the wrong resonance or at the wrong frequency, and you're putting it into the subatomic realm where there's no friction, and so it can go much, much further. But that's the difference between this, me just waving my hand and me waving my hand fast enough where I break the sound barrier and create little sonic booms. Alright, why does optics need to move faster than the air molecules? Why do objects need to move faster than the air molecules to produce sound? It's not faster than the air molecules, it's faster than the speed of the transmission between atoms of electrons. But regardless, when the air molecules can collide with the object just by moving in the opposite direction and gain more momentum. Yes, I'm sure that does happen now and then, but that's a tiny percentage of the overall sound that's being created. So it's a tiny percentage of the energy that's being every time there's a frequency, there's other frequencies traveling with the frequency, some a little higher, some a little bit lower. And those are all examples of some of the energy was moving forward towards the thing when it hit it, and some of the energy was moving away from it when it hit it. So yeah, there's going to be cases when the atom hits another atom that's moving towards it or moving away from it, and it's going to create a little change in the frequency. But that's tiny changes. I found another video demonstrating momentum. Not sure if you've seen this one too, but I don't think so since it's not on YouTube. I'll send you later. Yes, do that. You're sure it's not on YouTube? Yeah, it's not too many places now that provide their own video. They always dump them on YouTube. Yeah, well, it being available on Facebook doesn't mean it was uploaded on Facebook. But I can't play Facebook, so, I don't know whether I'm going to be able to play it because I don't have a Facebook account. I still don't even know how Facebook won the Facebook wars. I don't even know how that happened. It's such a creepy place right from the start. Oh, it's the little Heil Hitler guy again. I literally forgot the name. Damn, hate when that happens. Forgot the name. Forgot what name. There's this other YouTube pro platform that is less censored. Yeah, so what? There's like 10 of them. And yes, nobody will see it and no one cares. So what's the point? And they all have their dream of one day screwing the audience just like YouTube did. They all just want to create something they can sell for big bucks. That's all they're after. So they're guaranteeing you nothing regarding a future. Yes, you could download it, you could record it, on your own PC, just play it and record it or something, I suppose, blah, blah, blah. Or maybe you could see if it has a share link or something. Maybe it's shared someplace else. Maybe you could see it, but who knows? But yeah, I do not do Facebook. I think it was Rumble. I don't know what that means. Oh, that's the website you're talking about? Yeah, well, whatever. I'm sure it's Bumble. Yeah, well, everybody has their agenda. There's lots of agenda out there. It's a sad fact that you have to play the game by these stupid rules. Always have to wear somebody's uniform. We'll get to it if you have a question. Preambles to questions annoy me. Can I ask a question? Can you get to the point? The video is demonstrating a torque lever. Torque lever. I don't know exactly what a torque lever is, but okay. At what point will the subject of KE versus MV be satisfactory for you? I don't even know what that means. Clearly, I'm going to fight for the win, so all of science is going to be decimated when I get done with it. So I'm going to burn their whole house down, because KE is a plague of blight. It's just pus. It's a disgusting infection that's destroyed rational physics. So once KE is pulled out, all of the antimatter goes away, dark matter goes away, all of the 5 million particles they've invented, quarks, go away, all the crap goes, neutrinos disappear, all of the shit goes away, and you end up with rational physics. So yeah, I'm only going to be done when I'm done. When I'm done defeating the pus monster, then I'll be done. But until then, I'm in the fight, because I know I'm right, first off. It's just goddamn fucking obvious that KE is nonsense. We lost half the energy, but we have the same momentum. I mean, just think about that statement. We lost half the energy, but we have the same momentum. I mean, what the fuck? It's retarded. I mean, Newton would literally just blow his brains out if he knew this is as far as we got. After the platform he built for us, the boat we built for us, and we sailed into a sewage plant with it. He'd be like, "What the fuck? I built you a boat so you could sail to the sewage plant? I mean, what are you fucking people retarded?" Well, it's nice that somebody agrees with me now and then. It's not quite enough, but it's better than nothing. Don't know if it changes anything. I mean, obviously, I agree with me, and my opinion is the opinion I respect more than anybody else's is my own. So as long as I know I'm doing the right thing, then I'm satisfied. I've been coming to your streams, and I'm in support of your example compared to Ian Gosling, Brozo, and the likes. Well, that's a pretty poor comparison. The fact that I look a little more rational and reasonable than those lunatics doesn't mean much. So again, that's sort of a backhanded compliment. Yeah. Well, you make them look like idiots. Oh, like that should be hard work? No. I should be making them look like idiots so much better than I'm doing it, because they are such fucking obvious idiots. I mean, Brozo really believes in this 1.4 thing. He thinks it's all over the place, that the whole world runs on it, that you can't throw half as light baseball twice as fast. He thinks your arm will break or something. You can't do it. I mean, they really believe there's some sort of rational reason to think an 8-pound ball going 16 miles an hour crashes into pins and somehow it can give them more energy. Somehow it can distribute its momentum in some way to make the pins move more distance, more stuff, do more things in the universe. And it's just, how can people believe that? How can they think something other than momentum is necessary? I mean, how can they think they can cause action without momentum causing the action? How else does the exchange take place? How can you exchange this kinetic energy crap? It's unexchangeable. I don't mean to be such a shithead. I mean, I know I'm just coming off as such an arrogant fucking shit, but I've been doing this too long. I mean, it's, it's like it shouldn't have taken this long. I wanted to be done with this project before my father died, just so I could say, see, I wasn't as big a pain in the ass as it appeared. I wasn't as big a loser, okay, as it looked. But that didn't happen. So that was disappointing. But I mean, I never really thought that, I would, actually come up with these really insightful ways of viewing the mechanics, and have to do all this work to convince people that your evidence sucks and my evidence is really great. It should be kind of obvious that your evidence sucks. That all the things you say are true. You don't have shit for evidence. It's all wooey, made up, indirect crap. And, I can draw you really straight lines to the truth. Not much of a compliment when these people aren't even honest to begin with. Yes, and like the two-slit thing. I mean, the fact that I dissected the shit out of that and I figured out all kinds of, truths about the pattern and how it's created, and the fact that it really is two single-slit experiments just smashed together. But the key thing to understand is it's not this surface and this surface and this surface and this surface anymore. It's these two surfaces and these two surfaces. And that's the difference. And it's a huge difference. This distance, the furthest distance between two surfaces between, this slit and this one and this one and this one is gigantic. So you can really simply understand, oh, that's all there is to it. It's not all that mysterious after all. It's just that this and this are different than this and this. It's so obvious. And so big as an idea. It's a gigantic way of understanding the slit experiment, that it's just about the fucking surfaces. The surfaces define the whole experiment. Every bit of the math is just measuring the distance between two surfaces. Everything that happens on the surfaces. Shit, it's this, the single slit is the two surface experiment. The double slit is the four surface experiment. I mean, those are gigantic insights for, and the fact that I can't get anyone to concede, oh yeah, that does make an awful lot of sense. And instead they stick to their entangled wooey. It goes through both slits. It doesn't know who it is. It's superimposed on itself. It's all this stupid shit. Instead, this wacky, wavy bullshit. I mean, I point out that the wave comparison doesn't even work for the single slit. There's no interference pattern with a single slit in waves. Yes, exactly. The fact that it's a push universe, for fuck's sake, it's just so goddamn obvious. Pull is merely a misunderstanding of the push. It's just a bad point of view. So anyway, I guess things are winding down enough where I guess it's time to probably go and get some other crap done. Blah, 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 blah. So, let's see where... I'll see what the hell's happening here. See how many people are here, whether I'm leaving too soon or leaving too late. What does it say? 13. Yeah, it's right in the middle. Yeah, it's not enough to stay. It's not compelling. Why does this always change? It should be on analytics. So that's 14. Alright, so it's really not worth hanging around for, I guess. So we do have to increase the numbers somehow. Just a little bit. You know, it doesn't have to, like, double the amount would be just about right, probably. Where's the other window? That's weird. Where's the stupid chat thing? It's gone. Somebody stole it. Oh, there it is. That's probably not it. That's probably it. Alright. Let's see what this was here. Alright, I sent you a YouTube video that's somewhat similar to the experiment I found on Facebook. Change isn't easy. Admitting a mistake is harder than physicists without ego. Still searching honest scientists. Perhaps there's a point one can't learn new things. Well, if that's true, then, you know, it's even more disgusting a fact that all these scientists don't have any real passion for the truth. And my brain sort of won't go there. I mean, as much as I am pissed off and angry and disgusted and all that kind of stuff, I still think that underneath they really do have to, you've got to be able to hit an integrity button somewhere. And yeah, all these show scientists are really shitty ones, okay? That's the fact. These public make money off science prostitutes, you know. Yeah, I mean pimps, you know, pimping science. Yeah, I probably shouldn't expect integrity from them. You know, the Veritasiums and the physics girls and the rest of these asswipes are all full of themselves being teachers. You know, yeah, maybe you can't expect integrity from them. But it just seems to me that there's got to be some way to reach the rest of these scientists who are really saying, yes, the truth is everything. And they would have to admit some kind of truth, like, well, yeah, there's 400 times better resolution from space, you don't need an eclipse, and the experiment only takes 5 minutes. Well, we sure as fuck should have done that experiment by now. You know, we should have repeated the Eddington experiment. Yeah, that certainly should have been on the schedule somewhere. I think that's an integrity test. If a physicist can't utter those words that, yes, they should have repeated that experiment by now from space, then they'd have no integrity. Then they're showing themselves to be a Pyrrho. You know, they don't care about the truth, or a Brozo. They don't care about the truth. Because that's a real integrity test. Because in my opinion, there can be no excuse for that. There's just no way to make an explanation and say this fundamental experiment, key to this one of the biggest ideas, you know, Time's man of the century, Einstein, and you didn't repeat the foundational experiment. I mean, that's a glaring unethical science. That's cheating science badly. That's a really bad, nasty cheat. Since 2016, your first live hangout have been noticed that we are noticed, but why shadow you? I can't get it. I don't know what the fuck that means. Your first live hangout. 2016. Yeah, so what? That's whatever, old YouTube. I've been noticed that we are noticed. I don't know what that means. But why shadow you? I can't get it. I don't know what that means. Shadow. Well, I'm off. Thanks for the stream. Yes, I'm also off soon, maybe. Them bellies are full. What the fuck are you talking about? Sorry. All of a sudden you're speaking Japanese. I don't know what the hell you're talking about. Shadow banning. Oh, I don't even know what that means. I mean, you know, I think the banning isn't really shadow banning. I mean, I think they obviously YouTube promotes certain content because they make more money on it, because the commercials are easier to place on it. The commercials they get more money for are on it. You know, all kinds of reasons why YouTube likes certain content, like kittens, and doesn't like, you know, snarky. What he's saying is, thank you, that would be really nice. Your content might be shadow banned. Well, I mean, clear to some extent this is obviously true, but it's shadow banned. All of YouTube is shadow banning. Look at the guy I pointed to yesterday. All right, for 3 years he's been making pretty good physics instruction videos. I mean, if you're, you know, I mean, yes, I don't believe the physics he's teaching, but I'm just saying they're quality teaching videos. And, you know, in 4 hours he got 2 views. You know, I mean, what the fuck? Does that make any sense? 3 years and, you know, his videos get, you know, 200 views or something. I mean, it's pathetic. And it's because YouTube is broken. Okay. So, yeah, yes, frankly, I do believe that YouTube knows who I am and does not like me. Okay, I believe that is a truth. But that isn't the whole story. The whole story is Google absolutely is evil and it sucks. Okay, and it really doesn't want to, it wants to own the content it produces. It wants to make the most money possible from your presence on YouTube. It wants to shove content in front of you that is money making for them, and that's the real game. All right, as in not promoted or purposely hiding it. Yes, okay, who cares? It doesn't matter. It doesn't matter what the truth is in this point. The point is this is the world I have to function in. So in that world, I have to manage to, you know, expand the audience for this argument, because the audience that exists just isn't good enough yet to have the argument. I mean, there isn't enough qualified participants in the sense of people who have done enough research. I mean, obviously, in this audience, I'm probably the most outstanding expert on Leibniz or Descartes. You know, I could probably beat any one of you in a, you know, argument about what happened or what they did in their life or what they said or all that kind of crap. And what we need is somebody else in the conversation who has that kind of depth of understanding regarding the individual subjects. So I'm not calling you people stupid. I'm just saying, yeah, there's no reason you would have done all that research, because the only reason I did the research is because I knew there was something wrong with the theory, and I had to go find out where the wrong happened. And I found out it happened right from the very beginning, though, you know. And the irony is Leibniz decidedly lost the argument. So he suggested this 1/2 mv, you know, he suggested the mv squared thing. And he just lost so decisively. I mean, only a few little weird fanatics were Leibniz followers. And he died. No one. I mean, nobody cared. Nobody paid to bury him. Nobody gave a shit. Okay, they just basically swept him into a hole in the ground. He was a nobody, and they buried Newton as if he was Jesus Christ. So clearly Newton won the day. And then they dug this up, you know, 25 years after Newton's death, because of a tutor. So this stupid Deschartelet woman, this French woman, was tutored by a Leibniz fanatic, you know, one of the old leftover cult members of the Leibniz cult, the believer in the soliton and the monad, you know, the nutty package of Babel. And that guy is what he's the piece of the plague that survived the cure. You know, so they were cured, but the little piece of the smallpox was still alive in this little cult member, and he spread it to all of France and destroyed science. It's just kind of a funny story. Anyway, just. So who's going to bother doing all of that research, right? I mean, yeah, you know, you got to have a reason to do it, and obviously nobody else had the reason. For whatever reason, everybody was perfectly satisfied with thinking this 1/2 mv squared thing made sense. When as soon as I looked at it, I said, what the fuck? They believe that? Why is all this shit in there? This shouldn't be complicated. It's fucking momentum. What do you mean? Momentum isn't 1/2 mv squared. But anyway. So that's where we are, and I'll try to do my best to, get the job done, of mankind's re-education. But it's so far not so great. But I do have hope for the future, so that's all I can do, is hope that things will go better and such. So that will be good enough. So till the next time, appreciate the interaction, what there was of it, and what was rational and relevant. A little bit. Anyway, so till the next time.